Hello, and welcome to another math course, or your first math course if you haven't taken these with me before. In this one, we are looking at Chapter 2 in the textbook that you will have received from your teacher. The textbook is called Common Core Achieve, Mastering Essential Test Readiness Skills for the High School Equivalency Exams. And I'm going to be working these problems in a digital notebook. At the end of the course, I will provide the finished notebook to you, and you do have my permission to copy my notes for your personal use. You may not put these notes on another website or share them in any way. They are just for your personal use. So let's take a look at page 48 in the notebook, or in the textbook. This is called Apply Ratios and Proportions. And we're looking the chapter starts on page 47. I'm not going to be reading all of that to you, but I encourage you to read the margins, especially of the textbook. Any key terms, I recommend flashcards for those. I think that's very helpful, but you and your teacher can decide how best to proceed. I want to start my notes on page 49 of the textbook. So I'm going to set up a section for this, and let me go ahead and label it for you so you will be able to reference it when you want to. And I'm going to call this lesson 2.1. And that's all I'm going to put on here. You just will be able to find the section you need in the notebook based on that number if you print the document. So looking at page 49, let's start off with some basic terms that you need to understand. And I'm going to have to increase my pen size just a hair. So page 49, I want to give you just some definitions as we go through. So I want to first of all define a ratio. A ratio is a comparison of two quantities. And it's always two. Always two. You may have to pick two quantities from 500 quantities, but the actual ratio is always a comparison of two quantities. So let me show you some examples or an example of what I mean. So I'm going to use my highlighter if this will work the way I want it to. I'm going to make, it's not going to work the way I want it to. So let me see if I can put in some, here we go. I'll use a heart and another heart. I am building a mathematical array. An array is a collection of objects or shapes, you could say. So let's do this one. And I'm just using what I have on hand here. You can compare anything. As long as you have two of them, you can compare all you want to. And I'm going to use this one too. Okay, so let's look at some ratios with these two shapes. You can also compare on the basis of color. So I could compare pink items to blue items. I could compare hearts to squares. I could compare large squares to small squares. I could compare hearts to all items. There are a lot of possibilities for this. So looking at this example, let's start off with the ratio, the comparison of hearts to squares. Okay, so I'm going to count the number of hearts, and there are 3 of them. And then I'll count the number of squares. There are 2 of them. So the ratio of hearts to squares is 3 to 2. What if I asked you for the ratio of squares to hearts? And you can copy this with me, or you can just print this, however you want to do it. Ratio of squares to hearts would be 2 squares to 3 hearts. So you see that the order is very important. The way that I'm asking the question is incredibly important. What if I asked you to compare the ratio of large squares to small squares? That would be 1 to 1. There's 1 large square, there's 1 small square. What if I asked you for the ratio of total items to hearts? This one, I've seen students struggle just a little bit with this one. How many total items are there in the array? That's the whole thing. There are 5. So I would put that first. How many hearts are there in the array? There are 3. So we would say that the ratio is 5 to 3. So at its most basic concept, this is what a ratio is. It's a comparison of 2 quantities. You can write your ratios in 3 ways. You'll notice that these all look the same except this one. That was not an intentional thing. I'm just so used to interchanging these that I just do it without thinking. So there are some different ways to write these. You can use the word to. This is the way that you will very often see it in a word problem. Learn to look for that word to, because it's very important with ratios. You can also use a colon. This little symbol right there is a colon. So this one I could write as 1 to 1. And this one I could write as 3 to 2, or 2 to 3, or 5 to 3. And it will just depend on your professors as to which form is used. They mean the same thing. So you can use the colon, you can use the word to, or you can use fraction form. So this one would be 3 over 2. This one would be 2 over 3, 1 over 1, and 5 over 3. So this is the fraction form of the ratio. So let's highlight that in green. Those are the fraction forms. And as you start to do the calculations, you're going to want to use fraction form. Now, I've seen students ask this question before, and it's a good question. Can we just reduce that to 1? Mathematically, yes, because 1 divided by 1 is 1. But in ratio form, remember what a ratio is. It's a comparison of 2 things. So in ratio form, you need a top and bottom. You need a numerator and a denominator. We will use that form sometimes with calculations, but for ratios, You want to always represent the top and the bottom. Okay, let's talk just a little bit about a unit rate. This is going to be an important term later on in mathematics when you're looking at chapters 5 and 6 and you're looking at functions and graphs. Unit rate will be very important. But this is also just a skill that will help you solve some basic problems. So it's important that you understand what a unit rate is. A unit rate is a ratio, so it's a comparison of two quantities that compares, if it's a ratio, it compares an amount to one unit. For example, $2 per pound. Maybe apples cost $2 per pound. So you have to know that per pound means 1 pound. So your ratio would be a comparison of dollars to pounds. There are your two quantities. And it would be $2 to 1 pound, or $2, I'm getting ahead of myself, to 1 pound, or $2 to 1 pound. Here's another one that's very common. 60 mph. What does that mean? 60 mph. That's 60 miles per hour. So there is the comparison of two things. 60 miles in 1 hour, or 60 miles to 1 hour, or 60 miles to 1 hour. And then here's another one. Let's do a flow rate. Let's do a typing speed. 120 WPM. Words per minute. So your comparison is between words and minutes. 120 words in 1 minute, or 120 to 1, or 120 to 1. These are unit rates because there is a 1 involved. That's what makes a unit rate. So let me ask you this question. Is this a unit rate? Could I say 12 gallons run from a water hose every minute? Is it the same thing to put minutes over gallons? Is that legal in math? 1 minute, 12 gallons, or 1 to 12, or 1 to 12. Yes, it is legal in math. It is a unit rate because you have a 1. However, I would strongly encourage you with unit rates to get in the habit of setting them up like this. Put the 1 on the bottom, and that will help you get set up for the chapter on functions. For now, it doesn't matter. You can flip the ratio over, no problem. But it's a good habit to have, to put the 1 on the bottom. So let me ask you this. Let's suppose that we have this problem. Let me just call it calculate a unit rate. And if you'll notice, I am following loosely the textbook examples. But if you want to pause the video and copy this down, you can do that always. And then start the video when you're ready. $3.60 for 1 dozen donuts. Now, a lot of students will tell me we already have a unit rate because we have 1 dozen. So you could write it that way. You could say you're comparing dollars to dozen. So it would be $3.60 for 1 dozen. That is true. That's a unit rate for 1 dozen. But what if we wanted to know the price per donut? For 1 donut instead of 1 dozen. How would we go about finding that? Now, you can do it several ways. I'm going to do it the most basic way for right now. So I'm going to start with this ratio of $1 over donuts, because I want to know the cost of an individual donut. So $3.60 is the cost for how many donuts? How many are in a dozen? And we'll assume this is not a baker's dozen that has 13. This is a real dozen, so that's 12. That is not a unit rate. But if I go ahead and simplify and say, okay, for 1 donut, how much would it be? You would say $3.60 divided by 12. Just put that through your calculator, and you are going to get 0.3, I believe. Your calculator will not do the 0, but let me be sure. $3.60 divided by 12, yes. You get 0.3, which is the same as 30 cents per donut. And that is the unit rate for donuts. So this is a unit rate. This first one is also a unit rate if you're looking at dozen. So what I want you to see here is that this bottom word, whatever label I'm using there, changes the problem significantly. So you have to be very careful that you put the correct word down there to set up your problem. Okay, let's go ahead and look at the Think About Math questions, and then we will look at how to do a proportion. So I'm on page 49, and this is the Think About Math. If you have the textbook, let's go ahead and take a look at those. If you need the textbook, you can get that from your instructor. Number 1, a 2-pound bag of lentils costs $3.70. What is the unit cost per pound? Well, I can set up a ratio of dollars to bags, but that will not answer my question. The question is, what is the cost per pound? So even though you can set up a ratio, just like we did with the donuts, this doesn't answer the question, so you don't want to use that one. The cost is $3.70, and the pounds are 2. So we want to break that down to 1 pound. So we're going to say 370 divided by 2 is $1.85. And let's write the answer all 3 ways. So we could say 185 to 1. or we could say 185 with the colon and a 1, and all of those mean the same thing. It's very important that you know that, because the test can put them in any form, and they expect us to know that they all mean the same thing. Okay, number 2. A 10-ounce can of corn costs $1.88. What is the unit cost per ounce? Well, I could set up a ratio of dollars to cans, but that doesn't answer the question. They want to know the comparison of dollars to ounces. Actually, to 1 ounce. So this would not help me. I know that $1.88 goes with 10 ounces. So let's figure out what 1 ounce will cost. So 1.88 divided by 10 is 0.188, or about 19 cents per ounce. So 19 to 1, or 19 to 1. I think rather than write this with a cent sign, this is what I would do. Use the decimal form of the cents. And I like the leader 0. You can do it either way, but I think that is more likely to be what you'll see in a math book. But again, all of those are the same answer. The form, it's just putting on a different outfit, but it's the same person in the outfit. Whether I have on gym clothes, dress clothes, pajamas, I am the same person, regardless of what I'm wearing. Okay, the last one of these, number 3. We have a box of 144 pencils. And by the way, that's called a gross. It's 12 dozen. So a gross of pencils costs $5.76. What is the unit cost per pencil? So we could set up dollars to boxes. We could set up dollars to gross, and I see that one quite often. But neither of those answer the question, because the comparison we're supposed to make is dollars per pencils. So 576 goes with 144 pencils. So let's divide to get the cost per pencil. 576 divided by 144 is 0.04, or 4 cents per pencil. And you could write it in that form. You could write it in this form, or my preferred form is the fraction form, because the fraction form is set up for me to do math. And we'll be doing more of that in the next section.